Hello, welcome to this week's Maths Kitchen Homework Club. I'm James. I run Maths Kitchen, which is this Facebook page, as well as I've got a YouTube channel, Maths Kitchen. I'll put some links down below after the live thing. So the point of the YouTube channel and this Facebook page and everything I do really is to help people with the maths, to help you with your maths. Whether you are, whatever your ability really, whether you're year 7, year 11, or whether you're a parent. I tend to have a bit of a focus on GCSE, but really I'm here to help anybody, okay? And I do this homework club every Sunday at 5 o'clock on Facebook Live on my Facebook page, Maths Kitchen. Oh, there's one person watching. Okay, right. So I had this request from, here we go, Untitled. So that was a few days ago on my YouTube channel, and they asked, please could you do indices, for example, 1/3 raised to the power of 2. Okay, so that's what we're going to look at today. We're going to look at when you raise numbers to the power of something. Okay, so let's get stuck into that. Let's get a new whiteboard. Wonderful. Right. So when we talk about indices, that's another word that we use when we're talking about powers of numbers, okay? And we call them indices because this is what we're talking about. Whoops, this kind of thing. When you've got something to the power of, let's zoom out to 100%. That's more like it. If I've got something like 3 squared, the 2 there, you can say 3 to the power of 2, or you can say 3 squared. But this little number here, the 2, we call that an index number, okay? And indices is just plural for index. That's why sometimes you hear these referred to as indices, okay? So when we've got something, let's do that a bit neater. I've got 3 squared. That just means that I'm multiplying 3 by itself. 3 times 3. Okay, which is 9. 3 times 3 is 9. Let's say I've got 5 to the power of 3, which we write like that. You could also say 5 cubed. Okay, that means the same thing. And that just means I'm going to multiply 5 by itself, and then I'm going to multiply it by itself again. So 5 multiplied by 5 multiplied by 5. Okay, so 5 times 5 is 25, and then if I multiply that by 5 again, so 25 times 5 is 125. So 5 cubed, or 5 to the power of 3, is 125. Okay, so whatever that index number is, you just multiply the number by itself that many times. Okay, let's say I've got 2 to the power of, let's say 5, okay? 2 to the power of 5. That just means 2 times 2 times 2 times 2, and one last time, times 2. And we've got to work out what that is. So 2 times 2 is 4, times 2 again is 8, times 2 again is 16, and then times it by 2 one last time is 32. So 2 to the power of 5 is 32. Okay, so that's what powers, that's how powers of numbers work, and that's, like I say, we call those indices as well sometimes. But the question was to look at ones involving fractions, okay, which I'm going to get onto in a minute. But just before I do that, I'm going to look at some of the sort of basic rules when we are multiplying these indices together and when we're dividing them as well. So let's get rid of all of that. Perfect, right. Let's say I had something like 2 squared multiplied by 2 cubed. If we think about what's going on here, we've got 2 squared, or 2 to the power of 2. That means 2 multiplied by 2, 2 times 2. And then we've got to multiply that by 2 cubed, right? And 2 cubed, we now know, just so we're going to multiply that by 2 cubed. 2 cubed is just 2 multiplied by 2 multiplied by 2. If we're multiplying that whole lot together, we could write that the shorthand way of writing that, well, we got 2 times 2 times 2 times 2 times 2. That is just 2 to the power of 5. Okay, so 2 squared, or 2 to the power of 2, times 2 to the power of 3 is just 2. Ooh, run out of room there. Is 2 to the power of 5. Okay. Now I wonder if I can I do that? Ooh, that's clever, isn't it? Right. So I'll leave that first bit there. God, that's good. Right, I'm going to do a couple more examples. Oh, I lost somebody. Okay, right. Let's say I want to do 3 to the power of 4 multiplied by 3 squared. Okay, so 3 to the power of 4 is just 3 times 3 times 3, come back, times 3 times 3. And so that's the 3 to the power of 4. Then I've got to multiply that by 3 squared, which is just 3 times 3. Okay, if I put that whole lot together, you can see we've got 6 3s listed there. Therefore, it's just 3 to the power of 6. Okay, so 2 squared times 2 cubed is 2 to the power of 5. 3 to the power of 4 times 3 squared is 3 to the power of 6. There we go, there we go, there we go, there we go. Right, 3 to the power of 6. You may have noticed, or you may have worked out that to get this number, the index number in our answer, you're just multiplying, you're just adding the 2 index numbers in the question. So 2 add 3 gives you 5, 4 add 2 gives you 6. Okay, and that is all you do in every situation. So 18 to the power of 5 multiplied by 18 to the power of 7 is just 18 to the power of 12. Right, just add those index numbers together. Add the 5 and the 7 together. So 18 to the power of 12. If you're dividing, you do the opposite. You subtract them. Okay, so let's say we had 7 to the power of 8 divided by 7 to the power of 5. So it looks like a fraction, but that just means divided by 7 to the power of 8 divided by 7 to the power of 5. We just subtract this index number, the one at the bottom, from the one at the top. So that would be 7 to the power of 3, or 7 cubed, we could say. All right, 7, let's do another one. 6 to the power of 4 divided by 6 squared. We just subtract this bottom index number from the top one. So it's 6, 4 take away 2 is 2, so 6 to the power of 2, or 6 squared. And that's true even if you end up with negative numbers. All right, so let's say we had 6 to the power of 5 divided by 6 to the power of 8. We still do the top index number take away the bottom one. So 5 take away 8, which is minus 3, okay? So that will be 6 to the power of minus 3. So don't be put off. Sometimes people, when they get the negative index numbers, or they end up with a negative number, they think they must have done it wrong and kind of just flip it the other way to make it. That's fine. If you get a negative number, it doesn't mean you got it wrong at all. Sometimes we get negative numbers. Right then, the last thing then, which is actually what Incentil was asking on YouTube. Let's get rid of all of that. What about when it's with fractions? What about if I've got something like a half, let's say a third, shall we? That was what he said. A third, and I'll put it in brackets like that, squared. Well, the rules are exactly the same. It just means that you're multiplying 1/3 by 1/3. So you need to be able to multiply fractions. I've got a video on that. Have a look at that on YouTube if you are not already aware. But multiplying fractions is actually really simple. You just multiply the numerators together. So in this case, 1 times 1, which is 1. And then you multiply the denominators together, which in this case is 3 times 3, which is 9. That's it, 1/9. So 1/3 squared is 1/9. Okay? Let's do a couple more examples. 1/4, let's say cubed, okay, to the power of 3. Well, that just means a quarter multiplied by a quarter multiplied by a quarter. We've done it 3 times because it's to the power of 3. Hi, would you be able to help with multiplying surds? Hello, Alexander Sorley Pring. Multiplying surds. But yes, possibly, or definitely. Have you got a particular question, surds question that you're struggling with? Otherwise, I will do my best anyway. I'll finish these off first. Good. So I've got to do 1 times 1 times 1, which is still just 1. And then the denominator will be 4 times 4, which is 16, times 4. So you double it and then double it again. So that's 64. So a quarter cubed is 1 over 64. Another way to think of it is that a quarter cubed is just 1 cubed over 4 cubed. Okay? Okay, I'm on it. I'll do that in just a second. Thank you very much for the question. So I'm looking down there. That's where I'm seeing the text. I'll do one final one of these, and that's how I want to do 2/5 cubed. Right, what I just said at the end here is really it's just the same as 2 cubed over, oh, my writing is terrible, over 5 cubed. All right, so 2 cubed is 2 times 2 times 2, which is 8. And 5 cubed, I don't know if you remember, it's one of the first ones I did, it's 125. 5 times 5, which is 25. And then times 5 again, 125. Okay, that'll work for any fraction. So I hope that was helpful. I hope that made sense. So now I've got a request for multiplying surds. So let's get rid of that. Oops, come back here. Where's my mouse gone? There we go. Right then. So surd, then, let's say, so surd is referring to the square root of something, in particular the square root where you end up with an irrational number. But for all intents and purposes, you can think of it as a square root that you can't work out what the square root of it is. Okay. So let's say I've got root 3 multiplied by root 3. So the square root of 3 multiplied by the square root of 3. Hang on, I'll come back to that one. Let's start with some easier numbers. Let's start with, not with surds, but ones that we actually do know the square root. So let's say we've got the square root of 16 multiplied by the square root of 16. That is going to be, the square root of 16 is 4. So in other words, we've got 4 times 4, right? So 4 times 4 is 16. So when you multiply a surd by itself, it has the effect of just getting rid of that square root symbol. But what about if we had something like the square root of 9 multiplied by the square root of 4? Okay, well, actually, the nice thing is that that is just the same as the square root of 9 times 4. Okay, so you can take those two numbers and write them underneath one square root like that. The square root of 9 times 4, well, 9 times 4 is 36. So that's the same as the square root of 36. The square root of 36 is 6 because 6 times 6 makes 36. Okay, so you can just multiply those two numbers together and put them underneath a square root sign. So for example, let's say we had the square root of 8 multiplied by the square root of 2, or root 8 times root 2, you could say. That is the same as the square root of 8 times 2, which is equal to root 16. And the square root of 16 is 4, because 4 times 4 makes 16. Okay, so that's the kind of, whenever you're multiplying surds, that is the underlying sort of principle that will guide all of the answers. Even when you get onto much more complicated ones, it's always that exact idea, okay, that you can put those together, multiply them together, and find the square root of that. I'm going to move on to a couple, sort of when we might do it the other way. So let's say you've been asked, because this is possibly what you've been asked to do, for example, let's say you want to simplify the square root of 72, okay? We're going to use that idea that I just showed you, but in reverse. We're going to kind of do it backwards. So I know that root 72 is the same as root something multiplied by root something. And I know that I can do 36 times 2. In fact, I'm going to do it that way around. Root 2 times 36. The reason I chose those two numbers is because 36 is a square number. I know how to find the square root of 36. Okay? I don't know how to find the square root of 2. Well, the square root of 2 doesn't give me a nice whole number. So I'm just going to leave that as the square root of 2 multiplied by 6, because the square root of 36 is 6. And we would write that this way around. Actually, we would say that is 6 multiplied by root 2. And we don't bother writing the multiplication symbol in there. 6 root 2. So that's why it's useful to know how to multiply surds, because you can use it the other way around for simplifying surds. I'll do 2 more examples of that, and hopefully that's been helpful. I don't want to go on for hours and hours, so I'll do 2 more examples, and I will leave it there. Let's say I want to simplify root 300. I want to break that down into factors. Okay, I want to do a square root multiplied by a square root. Now there's 2 numbers that are going to multiply together to make 300. There are lots of different numbers I could choose, but I want one of those numbers to be a square number so that I can easily find the square root of it. Okay, so this is always the process. You split the number that you've been given up into 2 factors, ideally or hopefully where one of them is a square number. So in this case, I know that, and this just comes with practice, I can see straight away that you can do 3 times 100 will make 300. And that's a really good one to choose because 100 is a square number. It's 10 times 10 is 100, right? So that is root 100 multiplied by root 3. Okay, and the square root of 100 is 10. And the square root of 3, well, actually, I don't know. It's not going to give me a nice whole number, so we will just leave that like that. Okay, so 10 root 3. One final example. Let's say, what should we say? Root 98. Okay, so exact same thing. I'm going to look for 2 numbers that multiply together to make 98, where one of them is a square number. And this, you do need to be pretty good at your times tables to sort of be good at these. But, you know, again, it's just practice and getting used to it. So I also know the answer because I just made up the question. But I can see that I can do 49 times 2. Okay, so root 49 times root 2. 49 times 2 is the same as root 98. And that's really good because I know that 49 is 7 squared. Okay, in other words, the square root of 49 is 7 times root 2. Tom Wilmington joined. Hello, Tom. Nice to have you along. There we go. I hope that was helpful. Either let me know if not, or if there's any other questions you needed me to do. Otherwise, I'm going to leave it there. Tom, you got any questions I can help you with? No. Okay. All right. Well, listen, thank you very much for joining me. Those that did, thank you very much for your questions, Alexander and Incentil, which was from the YouTube. Don't forget to have a look at my YouTube channel. And if you have any questions, put them on my Facebook page or on my YouTube channel. You're welcome. You're welcome. Excuse me. Yeah. Any questions, leave them during the week or over the weekend, anytime, and I'll do my best to answer them. Thank you very much for watching. I will see you next week.